what we're doing today is exactly what we're doing in Target B, but we're going to take it up a notch in Target B. So today is going to feel kind of simple based on what we've been doing, but it's extremely important leading into Target B. All righty. So we are on page 9 in the notes. Page 9 in the notes. And so we are going to be Target A, day 3. And so we are going to be simplifying rational expressions, which we have already done this in this class. But first, let me just define it for you, and then we're just going to do a whole bunch of examples. But for simplifying rational expressions, that's when an expression has no common factors in the numerator or the denominator. So let's just write that down, and then I will tell you what that means in more familiar terms. But it's when an expression has no common factors. When an expression has no common factors in the numerator or the denominator. So when we simplify a rational expression, it's when the expression has no common factors in the numerator or the denominator. And we've been doing this in this class. You've been doing this in math for a long time, and we've been doing this specifically in this class without realizing it for a while. When I tell you to simplify your answer and simplify a fraction, that's what we've been doing. A rational expression is when we simplify a fraction as well. So if I tell you to simplify 15 over 21, I'm telling you that that simplifies. We can take a number out of it and simplify it further. Now, sometimes there's shortcuts. Sometimes your calculator can simplify. If your equation has no variables, if your equation is just one number divided by another number with no x's or y's or anything, we can just use our calculator. 15 over 21, I can simplify that to, let me clear this. I suggest you just do this part in your calculator, but you can do 15 over 21. You can take a 3 out of both of those. 15 over 21 in my Desmos calculator, I can hit the fraction symbol right here. I can hit convert to a fraction, and that will give me 5 over 7. So I can simplify this fraction by dividing 3 by both of these. I can take out a common factor of 3. 15 divided by 3 is 5. 21 divided by 3 is 7, and that's 5 over 7. You guys are remote, and I want you to take advantage of that, and you can use your calculator to help you. So you can take 15 over 21, hit enter in your Desmos calculator, and convert that to a fraction, and that will give you the most simplified form. The same way of when I tell you, hey, you have 2 over 4, you need to simplify that. You simplify 2 over 4 to 1/2. You guys naturally do that in your head. That's the same thing with 15 over 21. All righty. Now it's not that simple when we bring variables into it. It's not that simple when I bring variables into it. So I have 5x over 25x squared. I'm going to simplify the numbers, and I'm going to simplify the letters. So I'm going to first rewrite this. I'm going to rewrite this by expanding. So I'm going to keep the top as 5x. But I'm going to rewrite the bottom by expanding the exponent. Remember, the exponent tells you how many x's you have. This exponent of 2 tells me that I have 2 x's on bottom. So I'm going to expand it. So I have 25x times x. This exponent of 2 tells me that I have 2 x's on the bottom. So when I simplify, I'm going to simplify the numbers first. 5 over 25, I'm going to simplify that. 5 over 25, you either know that off the top of your head or you can throw it in your Desmos calculator. I can throw it in my Desmos calculator by doing 5 divided by 25. I don't want the decimal. I want to keep that as a fraction. 5 over 25, convert to a fraction, is 1/5. So I can divide both of those by 5. So that was equal to 1/5. And I'm simplifying. So the whole point here is to cancel what you can. I can cancel an x on top and an x on bottom. And so I am left with 1x on the bottom. So I can take 5x divided by 25x squared and simplify it to get 1 over 5x. And this is the math to show it. I simplify the numbers separately. 5 over 25 simplifies to 1/5. And x over x squared, one of the x's cancels and I have an x in the bottom. I highly suggest you expand, you take the exponent and you expand it to help you see how many x's you have in the denominator. So I have 1 on top that can cancel with 1 on bottom, leaving me with 1 on the bottom still. Alrighty, so the key here today is to cancel what cancels. Any questions so far? So we have done canceling before. We have done canceling in vertical asymptotes. Here in C, this is already factored for you. This is already expanded. Everything is simplified for you. Now I'm just going to cancel what I can. I hope you agree with me that since I have an x minus 5 on top and an x minus 5 on bottom, those cancel. So the whole key for simplifying is to cancel. I cannot cancel anything else though, because this 2x, there has nothing to do with an x plus 1 and an x minus 1. So everything that doesn't cancel, we just rewrite it. So this simplifies to the 2x that I still have on top, divided by the x plus 1 on bottom and the x minus 1 on bottom. So anything that doesn't cancel just gets rewritten. But you just want to clean it up. And we clean this up by canceling and rewriting. Okay. We have seen a problem like D before already. We have seen this already. But instead I said, hey, find the vertical asymptotes. You just are not doing that today. Today we're just cleaning up, which is why I would have probably put this in the first day of the notes instead before vertical asymptotes. But you are just simplifying. So when you simplify, you need to factor first. If you notice that these factor, you need to factor. In order to simplify, you need to factor the top and the bottom, which is what we've been doing. The tops and the bottoms haven't factored in our problem so far. The rest of our examples will have some sort of factoring, but if you notice in our examples, nothing has factored so far. So I'm going to factor the top and the bottom, which is what we've been doing. We have been doing this. So I'm going to find the factors of 6 that add to -5. Factors of 6 that add to -5. I have 1 and 6, 2 and 3. Oops, and I want them to add to -5. Well, both of these can add to -5. I could do -2 minus 3, or I can do -6 plus 1. I can either do -6 plus 1, or I can do -2 minus 3. Only one of these is going to work, and I have to think, okay, well, my eye on the prize is -5. I can get that 2 ways, but I need them to multiply to a -6. -2 times -3 is going to get me a +6 when I multiply them, so it's not going to be that one. All right, we need to get a little bit better at this part of factoring. Sometimes you guys move a little too quick and just pick the first number that you think. We got to think about this part. So this top is going to factor to x minus 6 and x plus 1, because -6 times 1 will get me a -6, but when I add them will get me a -5. Divided by, I can factor the bottom because remember, I have two things. This is what I want you to get better at noticing. I have two things that are being subtracted here. Two things that are being subtracted here. I can take the square root of both of them. I can take the square root of both of them, the square root of x squared and the square root of +1. You leave the subtraction sign out, and I have x and 1. So I take those two things and I add them together, and I take those two things and I subtract them by each other. So I have x plus 1 and x minus 1. And I hope you agree with me that the x plus 1s will cancel then after I get there. So I factored the top and I factored the bottom, which we've done that already when we find vertical asymptotes. I'm not finding holes and I'm not finding vertical asymptotes. I'm just canceling and rewriting. So the x plus 1s cancel, and my answer is going to be just what I have left. I have x minus, oops, I don't need to put that in parentheses. I have x minus 6 on top and x minus 1 on bottom. That's all that I am left with. Any questions so far? All righty. I have a couple more examples on the next page. Let's see some examples on the next page. Page 10. I'm going to do 2 more. Alrighty. In E, I need to, again, I'm going to factor the top and factor the bottom if I can. One thing you want to be very careful of is you want to always factor a negative. If the beginning of your problem has a negative, you need to factor the negative. Always. If your leading term is negative, you want that to be positive, always. If the first term is negative, you want to take care of that. So I want to get rid of that. So sometimes I have here -3x minus 6. I want to get rid of that negative. So I'm going to ask myself, I'm going to notice I have -3x minus 6. Let me write that over here. -3x minus 6. I hope you agree with me that I can take out a greatest common factor of 3 from both of these things. I can take out a 3 from the -3x, and I can take out a 3 from the 6. And since this is a -3 and I want to factor the negative, I'm going to take a -3 from both things. You always want to take care of the negative. So you're going to look for greatest common factor and take the negative form of that number. Alrighty, and then so when we do greatest common factors, we put that -3 on the outside, and what we are left with goes on the inside of a pair of parentheses. We've done this before. -3 divided by -3 is a +1, so I'm just left with x, because those will cancel. -3 or -6 divided by -3. If you need to use your calculator, you can, but that's going to be +2. Alrighty, so I took out a greatest common factor, had x plus 2 on the inside. I hope you agree with me that nothing on the bottom will factor. X plus 2 will not factor any. And so I'm left with x plus 2 on the bottom. And then I look to see if I can cancel anything. -3 is being multiplied by x plus 2. I can separate multiplication. Yes, I can. So I can cross out my x plus 2's will cancel. I can separate that -3 and that x plus 2. So I am just left with an answer of -3. Okay. Questions? Alrighty. One last problem. We're not going to do the problem on the bottom. Oh, wait. Yes, we are. Oh, wait. No, we're not. Sorry, I'm on the wrong page. So one last problem. We're going to do F. Again, if I ask you if the top can factor, you need to get in the habit of looking for a greatest common factor. So I'm going to rewrite 3x minus 15. And you want to get in the habit of looking to see if there's a number we can take out of both numbers. In the chat, please, in the chat, what number can I take out of 3 and -15? What number can I take out of both of those? 3. Good. So I'm going to divide both of these by 3. I'm going to divide both of these by only a +3 because my first number is positive. In this problem only over here, I took a -3, but that's because I needed to factor out the negative because my first term was a negative. My first term is a positive here, so I'm going to stick with positive numbers. So I'm going to take my greatest common factor of 3, put it on the outside. 3 divided by 3 is just 1, so I put the x there. -15 divided by 3 is -5. Okay. Divided by, now I need to factor the bottom. I want to find the factors of 15 that add to 2, or -2. So factors of 15 are 1 and 15. Oops, that's not how that works. 1 and 15, 3 and 5. Hope you agree with me that 3 and 5 will somehow get me to -2. And if I do -5 plus 3, that will get me to -2. -5 plus 3. So that would be x minus 5. If the 5 is negative, x minus 5, x plus 3. Righty. The x minus 5s will cancel. You're going to rewrite what you still have. 3 over x plus 3. Pay attention to this very, very carefully. You cannot cancel these 3's now. Don't write this down. You cannot go like that. You cannot do that. You cannot separate addition and subtraction. You cannot separate. You cannot separate. You have to know that. You can't cancel out the 3's. You can separate multiplication, which is why I can separate the 3 times the x minus 5 over here. You can separate multiplication. You cannot separate addition and subtraction. If that makes you feel better, you can put this in parentheses. You cannot separate things that are inside parentheses together. They are together forever. You cannot separate things that are attached like that. Alrighty. And we're not going to do the last problem.